Hello guys, this is Razor Game Dev, and welcome to the second episode on our entity component system built in with Love2D. So today on the agenda we have a few things. We're going to be really, or at least I'm going to be really trying to clean up the entity component system and make it a little bit more useful. Add a few new features and stuff. So yeah, let's open up our editor and get started. All right. So first thing I want to do is actually make it easier to create entities, because like when we create like bullets and stuff, we don't want to have to type in all of this stuff and every single time, things like that. So first thing we're going to do is I'm going to open up the world module, and right up here I'm going to make a new function. I'm going to call it world assemble. All right, and you're going to pass in a list right here. All right, so that list, that table, this is what it's going to kind of look like. So we're going to say player type, right? We're just going to create an array called player type, and in here we're going to make a table of tables. The first thing is going to be the first argument here is going to be the function, and then it's going to be the arguments for that function. So actually, I'm not going to do player. I don't know why I put player type there. We're going to do new body. So that's the function that creates the component. And right here, this is the argument. So we're just going to do, actually, let's move it over a little bit. Let's do 300. Next, we're going to say every player is going to have a rectangle component, sure. And the rectangle component doesn't take any arguments, so we're not going to pass in any arguments. And that's really all the components we have right now. So what I'm going to do is actually do local test is equal to world assemble. Going on assemble, and we're going to say player type. All right, so up here we're going to say for I v in components, or I pairs components do. All right, so first things first, we want to check that and make sure that the value is a table. So we're going to say type B is equal to table. If it's not equal to a table, we're going to say, in or world assemble requires a table of tables. I don't know. You can make a better error message if you want, but yeah, that's what I'm going to do right there. And then we're going to say local fn is equal to b at sub I, or sub 1. Oh, we're also going to assert that the length of b is greater than 0. And we're just going to leave that as an assert. If you guys can make your own error messages if you want, but I'm not going to bother with it. We're going to assert that this is actually a function. The first argument is a function. Type is equal to function right there. All right, now we're ready to actually use this. So if we're going to say if length of b is equal to 1, that means there's no arguments for the function. And the function, remember, is what creates the component. So we're going to say, up here, let's actually create an entity. So local ent is equal to self create, like that. Let's go back up here. We're going to say ent add, and we're going to add, let's just invoke the function. Just like that. All right, cool. So now if there are arguments, we're going to say local args is equal to a table. We're going to say for I is equal to 2. And then we're going to say till the length of b. We're going to do that. We're going to say table.insert into the args table. We're going to insert b at sub I. So basically that's grabbing everything that's after the function right here. So this is the function, and then everything after that's the arguments to the function. All right, and then over here, we're going to say function, fn right there. We're going to unpack the args table. So unpack basically distributes the table over the arguments in the function. It's a very useful Very useful thing. So now if we run this, we should see a second player. So remember, this is the first one that we had, and this is the one that we're actually assembling using the table. One thing that you could do that's actually a little bit easier sometimes is, let's just paste that there. Let's get rid of that, indent everything correctly, just like that. Now, expected a whoops, my bad. Let's go up to player type. Let's delete that. There we go. All right, so as you can see, we're creating the player now the exact same way. And this way, you can actually adjust the arguments and all that. And it's just a little bit of a cleaner way, because now you can save a table somewhere. And then every single time you spawn a bullet, you don't have to add all these arguments. All you have to do is pass in a single like player type or bullet type table. So that's a little bit more convenience. Another convenience thing that we're going to add is over in the entity. Well, actually, before we go over to the entities, let's do it right here. We're going to say we're going to return the system. Now, why we do that is because sometimes we want to actually use the system outside of the world, right? So if the system is like a physics system, we're going to want to add, separate physics systems that aren't entities, like bounding boxes and stuff. So now we can say local rsys or whatever, whatever name you want is equal to this, and then we'll actually grab the variable right here instead of having to create. It basically saves us on new lines. So that's useful, and then we're going to kind of do the same thing in entity over here. So let's go over to entity and let's go to add, and we're going to say return component. Now that's useful and all that, but we're also just as another convenience thing. Actually, I'm just going to copy this. We're going to add a new function and call it add or madd. That stands for multiple add. And what we're going to do is we're going to say self add component. And now instead of returning the component, we're going to say return self. If I can even spell it. So now what that does is now we can go over here, we can say madd, and now we can delete this, and we can have kind of a cleaner, more just a cleaner way to add multiple components. We can actually even, if we don't even want to worry about the instance, we can do something like this, which is a little bit nice. Yeah, see that? So we don't want to have a local instance, which is sometimes good. Sometimes you don't want to deal with that. You just want to dispose of, like, you don't want to have a local instance, to clutter your memory. I don't know. I don't think it's a big deal, but still. So yeah, a couple new ways to create entities. So one thing I want to do is I'm going to make a new module. I'm going to call it common component and make it a Lua file, of course. And we're just going to return a list of all these functions. And these are going to be the most common components that every entity is going to use, So we're going to say new body, and we're going to set it equal to function, like that. And then let's make sure we add a comma there. All right, let's just keep going here. Oh, and actually, this is a system, so we're just going to keep this in the main file right here. You would want to extract this away to a separate module probably in the future. But yeah, okay, so now we're going to want to include that. So we're going to say, oh, one thing, we want to include this over here, just like that. Let's require common components. Let's shorten this. Let's say comms. And let's include common components, like so. And then we're going to have new body. Yep. So now we can go to new body and just say comms. And that just kind of namespaces it and extracts it away. If you're making a lot of entities and you want to not have to type this, then maybe you can fix that. But yeah, so there we go. So now we have, we just have it all in one file, and we can go over here and edit it. And these are usually everything that's in this common component script should be pretty small components that you use everywhere. That way, you don't have to require all these different modules, which can it can be a pain to require all those. This just keeps them all together and all that. For big components like probably physics bodies will have a lot of values like velocities, frictions, stuff like that. You're going to want to have a separate file for that probably. So organize it however you want. This is just usually how I organize it. It may not be the best practice, but it's it's convenient, and conveniency is also really good. So one component that we're going to add right here, right? We're going to have a I don't know, maybe functional. And what this is going to do, because for one problem with entity component systems is that, a lot of times you want to specify specific AI for just like one entity, right? And that means you're going to have to create a system for that one entity and that one component for that one entity, and that can be very slow. That's not efficient in the slightest. So what we're going to do instead is we're going to create a lambda kind of invoking component, and I'll explain that in just a second. We're just gonna name it functional. For no reason really. Return it. Say functional dot fn is equal to fn. Sure, whatever. And now we're gonna create a new system also. We're going to name it new functional system, just like that. Let's just delete all these. Yep. Say we're going to match on all the entities that have the functional component. Let's name this. Let's just name this system, like lowercase system. Let's go back. There we go. All right, and then we're not gonna bother with the draw. We're actually gonna bother with the update. And I think it's DT then entity. Let me double check that though. Yep, it is. Okay, cool. All right, so we want to get the function from the entity. I'm going to say get functional, and we're going to say dot fn. Sure. Let's actually surround this by parentheses, and we're just going to invoke fn with the entity passed in. All right. Make sure we don't have any errors. Doesn't look like we do. Let's go back to our common component. Yeah, okay, so everything looks pretty good. So now if we want to specify some very specific, let's say this test player just moves back and forth, but we don't want the first player to move back and forth. Well, we can add a new functional component. Actually, I'm going to do it down here. I'm going to say test.add comms.functional. I think you have to do, yeah, just call it, just invoke it. And in here we're going to say function self, and then we're going to say end, just like that. Now we can just print hello world. Attempt to index 45. Why is test no? Oh, I know why. Let's go back to the world. We forgot to return the player at the end here. Oh, we should be good. So nothing's printing. Let's debug this. Why is things not working? Oh, it's because we need to register this, right? We need to register that system. So we're going to say new functional system. Now we're printing hello world. All right, guys. So that's really nice. One thing I want to do actually in our functional system is pass in the delta time also. So right here we're going to say self, and then we're going to say dt. And now we can do some fun things, like moving the player. So we can say local body is equal to self.get body. Then we're going to say body.x is equal to body.x plus dt times 10. One player is moving very slowly. Let's speed that up. Player is moving very slowly while the other player is actually staying still. So as you can see, you can create very specific AI for one single entity. All right, guys. So we're almost ready to use this entity component system, but there's a few things that we want to actually change and add a little bit. So first off, we want to be able to query different parts of, like, we want to be able to grab all the entities that have these components, basically, like get a list of them, right? So let's go over to the world and let's do that. And then we're going to say components, or let's say types, because this is going to be a list of strings. And I believe we could actually use system.lua, yeah, matches. So let's just grab this right here. Let's see. Let's format this a little bit better. All right, let's name this actually requires, just so we don't have to change any names. And we're gonna make a local table of entities. We're gonna if we do have that, if we match, oh, let me think. Okay, actually, better idea. Matched, sure. All right, so we're gonna say for entity for I, actually we want this to be very fast, so we're going to say for I is equal to 1, number of self.entities, do. All right, and we're going to say local ent is equal to self.entities at sub I. All right, and now we're going to check if it matches the components, and now we have to reformat this. Sorry for the jarring change in location. I was kind of pushing my luck being in the living room. All right, so where were we? Let's see. So we want to change this to ent, and let's actually format this correctly, like that. Okay, so if we don't want to return, we just want to skip this. Maybe we need to abstract this out to a separate function. Let's do that. I don't know. We'll worry about the arguments later. Wait. This is dumb. Let's go over to the entity. I'm very tired, by the way. That's why things aren't going as well as I want them to be. But oh, and this is not very. Yeah, this isn't very well planned. Anyway, okay. So we have an entity. We want to check if it matches all the requirements. So let's do something like matches. Make it false. No, actually start off at true. We want to return matched. Down here, we're going to say if, or let's loop through all the requires. J is equal to 1, number of requires. Do. Going to say if ent get j is equal to nil, then matches is equal to false. Now we're going to check if matches, then table.insert matched with the entity. All right, that looks good. Yeah, and I'm going to assume that works. All right, so at line 92, let's see what's going on. Okay, so we're missing something right now. We're missing an end. So let's check if it's in our get function. So get all with. So we have a for loop right here, for do, then match, and and we need an end right there. All right, we got it, guys. Cool. Now I'm not sure if this is gonna work, but I don't really have a good way to test it right now because I don't have enough of a game fleshed out. But we'll be working on a game in the next few days, and I think it's gonna be a platformer. Just because platformers will be a great way to show off the physics engine, be a great way to show off just I don't know, just a lot of things. Just a lot of things with the entity component system. So yeah, stay tuned for that. I hope you guys enjoyed this video. Please let me know what you think, and if you want me to do a different game or something next, or maybe there's an idea that, you know, it just didn't get through to you guys, and maybe I need to explain it better or something. I don't know. Anyway, thanks for watching, guys, and I'll see you in the next video. Bye. Oh, last thing before I end the video, I just want to mention that all of this will be on GitHub. Or GitLab, sorry, GitLab. The link's right here, but I'll be linking it in the description below. And this is where I'm going to keep all my tutorial videos, just kind of my engines that I make and all that for Love2D. Yeah, so let me just update it right now with the directory. So we made some changes today, so I'm going to add those changes. And now I'm going to git commit, let's say, cleaned up and made the ECS more feature rich. I don't know. Just I'm terrible at my Git messages. But anyway, let's push that. So yeah, you should be able to see the changes that I do throughout the series and all the future series that I do. Anyway, guys, thanks for watching again. Bye.